So we've just taken a look at how heterogeneity can be captured within a population through the form of parameters. We took a look at several textured aspects of that. So we introduced heterogeneity into a population, both continuous and discrete, looking at attributes on the continuous side like income and age, on the discrete side such as sex. We further explored how one characteristic encoded as parameters about a person could be contingent on another. So we could, for example, have income dependent on sex. The question was asked about multivariate distributions, where you want to capture covariances between multiple continuous attributes. And I noted you could, in those cases, you could either decompose it into multiplications of univariate conditional distributions, so probability of education levels, and then probability of income contingent on education level, something along those lines. Or you could actually draw from a multivariate distribution as supported by an external library. AnyLogic doesn't directly allow draws from multivariate distributions at this time. But again, by decomposing them into multiplications of conditional distributions, you can capture that. So another aspect of what we talked about was related to declaratively specifying the appearance of a model through the AnyLogic interface. So the first evidence of this, we associated people with an appearance specified by an oval, and that lent them a visual appearance on the screen. And we then went to the main class, and we set the layout properties for the main class to be random, and that distributed people around the space. As we'll see, that gave them a logical location as well as a kind of visual location, as we'll see tomorrow. But beyond that, we further set their properties visually, the properties of their oval, to depend on their characteristics. So we set their the oval color to be dependent on their sex, and we set the oval width to be dependent on their income. And those connections we maintained even over time. If income were changing over time, it will be maintained, as we'll see. So we saw some aspects of sort of AnyLogic's implementation of heterogeneous attributes and the way it can be linked up with visual attributes. A final component that we saw that I really want to emphasize, and it had some notes and discussions I had subsequently, is that within AnyLogic we have the ability to specify parameters at the individual level, at the level of an agent, at the level of main. And it's important to be clear about where you specify those parameters. The parameters, again, encode assumptions, and they communicate the assumptions from the point where the object with the assumptions is created. So if you have a person is created associated with a population, and so the population is the one that specifies those assumptions. So a person has an income, and the thing that specifies the income is the population of that person. The particular values to assume is a function of that population. For main, the thing that creates main is the experiment. And so if you have a parameter main, like population size, the thing that specifies the population size to use for a given run of the model is the experiment. The experiment will take care of creating main and running it. So when we have parameters, they encode assumptions, but they also communicate those assumptions from the point of creation. Later, tomorrow, when we add people into a population dynamically, when we have births occur, for example, or immigration, we're going to need to specify the parameters for that person to be created at that time. So wherever they're created, like with the population, or when we add them to the population, that's when we need to specify the parameter values. Does that make sense to people? Silence.
Needs to settle.
Needs to settle. Okay.
Well,
yeah. Alan.
Do the parameters always communicate upwards?
You communicate vertically. I tend to think of it as kind of downwards in the sense you have kind of main, and that's the higher level construct, and then and the population main sort of encloses people and then it communicates with the people down here. But yeah, they communicate sort of between levels. Yeah, exactly.
Can you repeat the last part you said about the person and the parameters that created, the established one that created?
Yeah. So a person's so we have a person class that describes personhood in our model, right? It associates them with an income, with an age, with a sex. That's part of their personhood is that they have a age, income, and sex. Okay, great. Now, what particular age do they have? We have to specify that. Let's suppose someone comes into our population through immigration. We have to specify their age, their sex, their income at that time. So we're going to add them into the population. We have to specify that. Now, for the initial population, which is specified by the population, that's where we specify those attributes for the existing population. So the population takes care of creating this whole population of people, 100 people in our original model. And for each of those people, it specifies the assumptions to be put into place for their age, sex, income. Does that make sense? Okay. People want me to expand more on that? It's a very useful construct, parameters, and one we're going to be using heavily during the boot camp. Okay? Okay, we're going to see one more important construct before the day is out. And that, ladies and gentlemen, is called a state chart. Okay? So thus far, we've been dealing with capturing the population. We've seen a lot. We created a personhood class. We created a population. We induced heterogeneity in that population. We used visual properties. We had coupled sort of aspects of heterogeneity. Lots has been going on. But ladies and gentlemen, thus far our models have been lacking one key thing to which we look to agent-based models, and that is, yes, changes of state, dynamics. They've been singularly uninspiring. They've been static in a most impoverished way. So we're going to now transition to examine dynamic models. Let us lend our models, ladies and gentlemen,